Hi everyone, and welcome to my YouTube channel. Today I would like us to look at momentum and direct impact. I'm talking, and for us to have a mastery of it, I would like us to solve this problem together. A small sphere A moving on a smooth horizontal floor with speed impinges directly on an identical sphere B, initially lying at rest on the floor. At the moment of impact, the line of the spheres is perpendicular to a vertical wall, which is at a distance of 2 meters from B and nearer to B than to A. B subsequently strikes the wall, rebounds, and strikes A again. The coefficient of restitution between all impacts involved is half. Find the speed of the sphere after the first collision. B. The magnitude of the impulse experienced by A after the first collision. And C. Show that the second collision between the spheres takes place at a distance of 0.8 meters from the wall. Okay, now this is a diagram describing, say A hits a wall B initially at rest, okay, and B has another impact with the wall and back again to hit A. So we have 3 impacts involved here. Okay, solution. Now, each of those impacts, we have to apply the law of conservation of linear momentum and Newton's experimental law or Newton's law of restitution. So the sphere A and B, the mass of A from law of conservation of linear momentum, MAUA plus MBUB is equal to MAVA plus MBVB. And we know that the mass of A is M, the initial velocity of A is U, the mass of B is M, C is identical, then UB is 0, C is at rest, which gives us this. And M cancels, so we have VA plus VB, that's VA, the velocity of A after the first impact, VB, the velocity of B after the first impact. That gives equation 1. From Mel again, we have VB minus VA is E UA minus UB, okay, and UA is U, UB 0, so half into half U. Now looking at this, solving simultaneously, to solve it, since you have VA and the coefficient here in equation 2 is negative VA, when you add, you are going to have 2 VB is equal to 3U over 2. If you divide both sides by 2, you have VB is 3U over 4, and VA is U over 4 meters per second. So that's the answer to B, to A. Now to B. The question in B is asking us about the momentum. The momentum. That's the impulse, sorry. The impulse by A. Remember, A is moving towards B. So the impulse you experience is negative JA. JA here is represent the impulse. So MU over 4 minus MU, which gives us negative 3 over 4 MU Newton second. So that impulse experienced by A is 3 over 4 MU Newton second. Now the C part, which asks us to show that the distance, that is 0.8 meters, the first thing is we have obtained VA, we have obtained VB. Now B hits the wall as illustrated above. As B hits the wall, each time when it hits the wall, the velocity now after impact with the wall is E times the velocity of B after the first impact. So E times 3U over 4, half times 3U over 4, which is 3U over 8 meters per second. Now, to be able to calculate this distance, we are going to know the time, T1, 2 meters from the wall. DA is 2 meters from the wall. Now, Knowing that VA, T1 is a time when we are talking about 2 meters from the wall. We know that distance, or when you have the speed is distance over time, implies the time is distance divided by that speed. So we have 2 meters over 3 over 4. So for us to be able to calculate the distance, to show that the distance is 0.8 meters, we've calculated VB after impact, that's velocity of B after first impact, was 3 over 4. Now, B is 2 meters away from the wall. So the time is 2 meters divided by 3 over 4, which is 8 over 3 seconds. Equally, when B hits the wall, that's after impact with the wall, we have our V prime B here, which is 3 over 8 meters per second. And the distance, when it approaches the wall, the distance covered now is a certain distance, x. Okay? So we have x divided by 3 over 8, which is 8x over 3 seconds. After hitting the wall, and coming back to strike A again, the distance now for A will be 2 minus x. 2 minus x. And what is the final velocity of A after first impact is u over 4. So we have 2 minus x divided by u over 4, which is 8 minus 4x over u seconds. Okay. Now, the time T1 plus T2 is equal to T3. That is the time for B, from B 2 meters to cover that time it takes to hit the wall, to have that impact, plus the time after having impact with the wall returning is equal to the time that A, when it covers that, it takes to cover the distance, that's 2 minus x, which is divided by u over 4. So these respective velocities here, we need to take note of the velocity. The first stage is this distance of 2 meters, and what is the velocity of B after that first impact is 3 over 4, right? Now, equally, the distance, remember A, it will not still be at 2 meters. It will shift a certain distance, x, from the wall, okay? Which you have x divided by that velocity after impact with the wall. The distance will not be the same again. Likewise, the distance of A becomes 2 minus x. You will see that when you take 2 minus x plus x, it will give us that total distance of 2 meters. So knowing that T1 is equal to T1 plus T2 is equal to T3, we have that is 8 over 3u plus 8x over 3 is equal to 8 minus 4x over u, okay? Which you solve for x here. Simplifying here, we have 8 plus 8x over 3u is, and solving for x, we have x is equal to 0.8 meters as required. That's 20x equal to 16. We divide both sides by 20. We have 0.8 meters. All right, thank you. Stay tuned. Have a great time.